Hi, good morning, dear students. Hope you all are keeping fine. Welcome to today's class. The last day we discussed about different types of sorting techniques. Today we are going to learn about dynamic programming and what are the steps to do dynamic programming. What is dynamic programming? It is an algorithmic design method that can be used when solution to a problem can be viewed as a result of a sequence of decisions. When there is a huge problem, a critical problem, you can divide that problem into different units or smaller problems and achieve many results, and you can find a optimum result from that, a best result from that. That is the use of dynamic programming. Dynamic programming is similar to divide and conquer method. The given problem is divided into smaller and yet smaller possible subproblems. So when there is a large problem which is critical or complicated problem, it can be divided into smaller subproblems. Those smaller subproblems can again be divided into another subproblems. So this is the approach made by the dynamic programming. Steps to do dynamic programming. The given problem will be divided into smaller overlapping subprograms. So when there is a huge problem, it can be divided into smaller subproblems to get a result. So when we divide this into smaller subprograms, you can see that each subproblem will give you a result. From those results, you can finalize or take the best result out of that. Dynamic algorithms uses memoization. What is memoization? Memoization is an optimization technique used primarily to speed up computer programs by storing the results of expensive function calls and returning the cached mem result when the same inputs occur again. So, again and again, when the same inputs occur, a particular storing technique is used, which is known as memoization. It is used for speeding up the computer's programs. So when the same result comes, it speeds up the uh, computer programs. Okay, so it does not wait for the same result again and again. The structural explanation of dynamic programming. So this, what you see, is a big problem. So this big problem can be divided into smaller problems. So these smaller problems will give you solutions. Solution may be a value. From these values, you can find the optimal value, the best value, or the suitable value. This is a structural explanation what we can give about dynamic programming. So a big problem can be divided into smaller units or smaller problems, subproblems, and from each subproblem you will be getting a solution, a value. From those value you can find the optimal value or the best value or suitable value for that particular problem. This is what about the dynamic program. Fibonacci series. We all know what is Fibonacci series. Fibonacci series generates the subsequent number by adding two previous numbers. So we know that. Okay, so let us see. So Fibonacci series satisfies the following conditions. So how to find the Fibonacci series, or how to write the Fibonacci series numbers? Fn equal to Fn minus 1 plus Fn minus 2, or Fib is given there. You can take f of n or Fn. It can be given anyhow. Okay, so this is the formula for finding the Fibonacci series. So here is a Fibonacci series, or we'll find a Fibonacci series for the value when we take n equal to 8. So first two numbers equal to f equal to 0, f equal to 1. So the third number will be 0 plus 1. The first two digits will be added together. So 0 plus 1. Then 1 plus 1. 1 plus 1 equal to 2. Then 1 plus 2 equal to 3. Then 2 plus 3 equal to 5. Then 3 plus 5 equal to 8. 5 plus 8 is equal to 30. So this is the Fibonacci series 0, 1, 1, 2, 3, 5, 8, 13. So you can see here 0 plus 1, then 1 plus 1, then 2 plus 3 is 5, 3 plus 5 is 8, 8 plus 5 is 30. So this is the way how we find the Fibonacci series. Okay, so that's all for today's class, and we are ending up the fourth chapter. So thank you. Have a nice day. Stay home and stay safe.